Good morning and welcome to the CADclass podcast. I'm Josh.
I'm Jake.
And each week we talk all things 3D printing, making, CAD modeling. We discuss and show off some of your amazing projects. And we say hello to you all in the chat. Feeling
I
pretty
think
good
over
this
a
week.
little bit of philosophy sometimes.
Little philosophizing.
Yeah,
from time to
we
time.
always end up on philosophy. It's like I always like to think, oh yeah, this is just going to be a normal episode. We're just going to chat about cool projects and that. And then we always deviate into existentialism, which I dig. But I'm always like, I'm devoted. It's just going to be about CAD and technical stuff. And we can never stay on that. Really,
We can't.
We can never.
It's
stay
not
on
possible. It's not possible.
No.
So good morning,
No.
Maple Leaf Makers. Maple Leaf Makers actually beat me to the stream today. So I came in and I already had a comment waiting from Maple Leaf Makers. So good morning, Maple Leaf,
All right.
BC Van Vliet, Derry, Spitfire, Cadence, Joe Street, Sam, Cornelia.
Morning, everyone.
Yes.
Josh, you're in a new place. You're in a new location.
I am not in the typical location right now. So I'm actually in Utah. I'm going to be spending a couple of nights in the backcountry out in Moab starting tomorrow morning, actually. So I'm in Salt Lake City and enjoying the beautiful mountainscape. And you can see I'm in my friend's house with just normal lighting. So yes, it was a little different today.
Not bad. Well, I don't think this is going to be a full hour podcast. This is going to be a generally, I think, a pretty quick one. But I do want to center this podcast around pure experimentation with CAD. We've had a few comments in our Discord and on our YouTube pages about some stuff that they want to see me do, and I'm sure they want to see me screw up just a little bit, which is fine because, as we say, I think probably every single week at this point, there is so many different parts of CAD modeling with every single different program, and there's different processes and techniques and styles, and I don't know everything at all. There is plenty of stuff that people go, oh yeah, you could just do that a little bit different. I'm like, that's great. That's awesome. I've been doing it a stupid way or the extra long way or the tough way for years and years and years. So absolutely every single time that somebody posts, hey, can you do this? I don't know. Let's try it out. So we got a couple things that we want to do. We have now a famous project that people have now been working on for weeks now to make a little spirally handle. I think it started off as like a blacksmithing project. And I've been commenting, oh, you should try this, you should try that, do this, without actually doing it. So we're going to be testing out today something that I think would work, may actually work, but who knows?
Yeah, I mean, it's one of the upsides of putting content, I think, out on the internet. One of the downsides is obvious. People skewer you for the mistakes that you make.
How do you not know this?
Yeah, right. So, but the upside is that you get to make some mistakes or learn new ways of doing things. Despite the sass that we get, the attitude that we get,
high sassafras.
Yeah, and I see Michael Wood here says, "Welcome to Utah. Good weather this week." So, thank you so much, Michael. Nice to be here, for sure.
Oh, what a good week. All right, so I think we'll start off, as always, showing off the awesome projects of our community. If any of you guys are new, every single week we like to show off some of the projects that people from our Discord are posting. Either they're working on their own projects, they just want to show off that they made something rad, or they actually took the projects from our Mastering Fusion 360 book or our course, trying out the challenges, trying out the projects, and they made something cool. So let's check it out. So I think the main ones that I want to show off this week was actually from some of our Sacramento Innovation Grant.
Yeah, so Key to Like, he was at the SAC Innovation Program, built the 3D printer, and that project right there, the blue, scroll up just a little bit there, right there. So he's a lockpicker and an amateur lockpicker, and he's been, I guess, doing this for a while. And he's wanted to make tools for his lockpicking things. And Jake,
which is so
we talked a little about this last week, but you also were a bit of an amateur lockpicker.
I feel like every single teenager that kind of grew up in the YouTube generation, we all just organically found random niche hobbies, and all of us were like, yeah, I can do that, with all of the hubris and confidence, with none of the skill. So I feel like so many of us found like lockpick lawyer, or people that were interested in like escapology, like, oh, I want to be able to like pick a handcuff, or like pick some padlocks or something like that. Oh, that seems doable. And then we all try it, and we all very, very quickly realize, wow, this is really hard. This is not easy at all. And
Yeah.
it's now so much more popular because of just some really, really rad YouTubers like Lockpick Lawyer, who makes these really kick-ass videos. And one of the very quick things that you realize when you're learning about picking locks is there are so many impossibly tiny and fiddly parts to padlock. I know it seems like a simple thing where you just put in a key and twist it. So many ridiculously tiny little bits of information come into this, and so making a little purpose-built holder is actually a really, really, really kick-ass idea. So this is I'm pulling from very little information. This looks like a 5-pin lock because I can count them. So essentially, of what I know, springs, that's what holds the pins in place. So as you put in the key, you can actually hear the little pins go up and down. And depending on the height of these pins at the top, that actually corresponds with the ridges on a key. And if they all line up, then you can actually twist it and then it opens up. And the idea with picklocking, I believe, is that there's an order of operation that you have to go through. So you can kind of put some pressure on the actual lock with something called a wrench, then go in there with a pick and actually feel the different orientations. And if you can get them in the certain orientation just by feel, then it opens up and it's awesome. I think I picked one lock and it was a 2-pin lock. So like one of the easiest things possible, and it felt like such a joy of success. But one thing that I do want to talk about is keyed alike. What were you saying a little bit later is can I fix the top layer with some fine sandpaper? And it kind of started a little bit of discussion that I want to kind of expand on. And that is, yes, technically you can sand any 3D prints. It's obviously soft plastic, but should you? Now, there is kind of one thought that, well, yeah, if you sand it, obviously it becomes smooth. You can essentially hide the layer lines, and it just becomes a nice, neat bit of plastic. But as soon as you do that, because you're literally roughing up the surface, then it turns very white, or it becomes incredibly pale, which gives you this really kind of horrible contrast. Because plastic isn't very hard, it means it will never actually become perfectly smooth with sandpaper. You actually need to apply a harder material like Bondo or car sealant or automotive spray paint that actually does become harder than the plastic, and then you can get polish on it, yada yada yada. But I think the different thought, and I kind of want to hear your thoughts on this, Josh, is that you shouldn't sand it to make it look pretty. You should just kind of accept the limitations and the surface quality of what you can get from 3D printing, and that just becomes an accepted quality. Now, obviously, as the tech gets better, quality does improve slowly but surely. But I think, as you can see in this picture, this is a really nice print. The actual top layers is lovely. It's really nice. I don't see anything wrong with this whatsoever from a 3D printing perspective. I'm sure someone who comes from a woodworking or a metalworking perspective is going to look at that and go, "Oh, that's rough. You can see all the lines, better." I disagree. What do you think about that, Josh? Yay or nay on the sand?
Largely, I agree. I think it's like the Japanese philosophy of showing the imperfections. Like that's part of the art. I think there are instances where if you're painting a mask and all you have is access to PLA, FDM style printer, and you're like, hey, I want to make this look great. I can see spending a little bit of extra time to spray it with some high build primer or to put some putty and smooth out those lines. And it's just like, it's got to be a labor of love. It's never going to be something that you want to do on repeat over some long period of time, and to your point, I think it's kind of fun to show off the fact that it's a 3D print. It doesn't have to look and feel like a part that was manufactured at a facility that does injection molding, right? And so I think, by all means, show off the differences, and then you'll get better and better, and you'll have smoother and smoother lines. And the more you dig into this, the more you realize, oh, if I could get it as close to right as possible, and I get a filament, like sometimes darker filaments hide the lines anyway. Sometimes
dark
filaments
filament,
have additive.
matte, or
And that
Sometimes if they
really
have
hides
like
the line.
sparkly stuff like
Exactly.
Galaxy, yeah, if you can get that, you will have the best print in the world without having to change a single feature on your printer or in your slicer settings. That's like the
Yeah.
best hack.
Yeah, I think that's largely the goal. And I know that when we were doing 3D printing as a service and we were making parts for other people, which we still occasionally do, but it's very limited now.
Mm,
But when we were doing that a lot, the big thing for us was we didn't want to post process anything. Part of the
no.
fun of 3D printing is that it can be made on autopilot on demand. That is, unless of course you have to pull it off and then sand it and then do all this stuff afterwards. It's like, well, that kind of defeats the point. It's I want to be able to pull this thing off and basically use it right away. So
Yeah.
yeah, to each his own. I can see why people would do it. And I think there was something else about this that I wanted to talk about too, and that is the ironing of that first layer. I have not
Yeah.
had much success ironing, and I don't tend to use it. Jake, do you iron any of the prints that you do?
Not really. So for everyone who doesn't know, ironing is the idea that as your nozzle is laying down the last layer, the very top surface, obviously it is visibly multiple parallel lines next to each other. And the idea with ironing is that you are basically rerunning the hot nozzle over that same surface. You're laying down just a tiny, tiny, tiny bit of material, but generally you are just increasing the temperature and you're having the radiant heat remelt that top surface, and then it can essentially becomes a solidly smooth surface. Great in theory, difficult in practice. What I've heard from a lot of people is that the default settings are perfect. Don't change a thing. There's lots of variability and lots of dials and switches that you can change. There's no need. Don't change anything. And then there is my experience with ironing, and it's, oh, that actually doesn't look very good with the default settings. So I haven't had a huge amount of success with it. What I would say, if you want to get a better surface finish, is instead of using ironing, change the top pattern to concentric. So the normal one is, I don't know if you can see it in here, where you can see it has the walls, so it's just tracing that perimeter, and then it's filling in that top layer with a 45-degree angle line, and that just kind of fills it in. It looks just fine. But one of the other things that you can do is change that pattern to concentric. So it's actually continuing that pattern all the way around, essentially circles becoming smaller and smaller and smaller until it's all filled in. And it just gives it a little bit more of an artistic, less functional, just visually looking at that a little bit better. So you still see the layer lines, but it just looks a little bit better. And I just prefer it. Ironing can be a little hit or miss. It also takes forever. It takes a really long time. If you're doing this entire surface ironing, that's probably going to add another 20 minutes to your print. I can imagine this probably being a 3-hour print. So it's a substantial amount of time. But for me, I don't really use it all that much. But I'm sure other people have gotten much better success from it, which is fantastic.
Yeah, apparently Darius said the bamboo ironing on the top surfaces looks really nice, but
Lovely.
followed that up with rarely use it. So
Yeah, it's
it depends on what you're trying to achieve. Like most things, it's like what's the desired outcome here? If it's the 0.01% difference here, and you want it to look just a little bit better when you pass it off to the client because you'll feel better about yourself, then fine, do it. But for the
yeah,
most part,
that's right.
I never touch the ironing. I try to get the layers themselves just perfect. And
Yeah.
really, like I think what it all boils back down to is spend time getting that first layer perfect. That's
Mm,
that's where I think if I were you, I would spend most of my time. Make sure the layer lines when they're actually put down on the print bed that they're connecting with each other in the way that they should be. And
mhm.
I spend all my time on that first layer, and most of the other sort of problems work themselves out. And also those end layers, if the first layer is put down pretty well, then you can be at least somewhat confident that that final layer will be better.
Yeah, I completely agree. It's just it's not the place that I really put my attention. But
Yeah. Yep.
but to be honest, Key to Like, what a fantastic project.
It's great.
I think this is the first thing they're posting, and it's rad. So hats off to you. This looks fantastic.
Yep.
Then we also got from
Yeah,
What the Dickens saying,
love
the
this.
new Lego set McLaren comes with terrible wheels, so I made much better ones. I dig that. I really dig kind of saying, yeah, this big manufacturer kind of blows. I'm but on this one part, I'm gonna make something better, and it does indeed look a lot better. So it looks like they're gonna be printing that on an XL with different colors on it. I've still yet to make something with multiple colors with a multi-head printer. I really, really, really want to. That's just so awesome. I love to see that. And then they post it on their principles, which is rad. So can't wait to see it. I actually kind of want to see if you can do that in black TPU. So it is actually made from rubber. But that's fantastic. Something from Eloreth. I can't remember if we went over this last week. But this is one of Joe Street's friends. He's just making a dead simple little headphone holder that just kind of snaps on the side of their print, snaps onto the side of their desk and just kind of holds their mouthpiece. That's rad. One thing I will say, if we have just a little bit of criticism, I think I can see the layer lines are actually horizontal in this orientation, which means that this large kind of plate actually only has a tiny amount of surface area where it meets this big place. And so if you're wanting to put your headphones on there and actually pull too hard, it's very likely that you could have broken that off. And so what I would actually recommend would be to print this sideways. So this angled face is actually touching the build plate, and then it's growing up at an angle. So it means the layer line actually starts from this face and is connected in kind of an L shape all the way around. So it'd make it just that little bit stronger. And I imagine you won't have any of the support material that you would need for this undersection right there. But that's something that is pretty minor. Rad project. Love to see it.
Yep.
Derriere, not very useful, but very satisfying. I totally agree. This is going to be one of the things that I'm going to try and make today in CAD to see if I can actually make anything better. And then Dom, I really liked this project. One of the most recent things that I'm proud of was a functional part to fix my buddy's brother's snowblower. Had some really weird angles, and it was fit the first time. So it looks like a little holder for a little holder for for snowblower, and it just kind of snaps into place and screws, and it's rad. I love that stuff.
That's actually like a fairly complex little design there.
I know, that's not simple.
No,
and that's awesome.
Nice. Yeah,
and it has little keys in it as well. Fantastic. All right, Josh, I want to actually get into this door handle thing because it's been bugging me for a while, and I just kind of want to get into it.
Show the original. So show the original photo of the door.
Oh gosh, where is it?
Yeah, it's up here.
So this came from. I actually can't remember who this was from. Was it from Dairy?
It might have been. Yeah.
I'm not quite sure. It was a long time ago.
If we can find it.
Oh goodness, I don't even know if I can find it. But the idea is that it is or it might have been in 3D printing discussion. Oh, I don't know. I have no idea.
I'll also look. Yeah.
Go and check it out. The idea is that you have essentially a handle that is connected to, or handle in an arc, and has a twisted section in the middle with a square profile all the way through, and it is perfectly normal square arc on either end.
It's in the challenge. It's in the challenge section. There it is.
All
yeah,
right.
There it is. So, and it was
there we go.
I think was it Connie or Derry? No, Derry did originally post it. Yeah, so Derry on 3/20/2024. So that's the door handle. Yeah.
So this is the original. So I think one of the problems that that they were trying to do, or they were trying to solve, is this little section right here, where it transitions from a square into a smaller arc. Yeah, this would be a lot of many rotations, and then a smaller arc, and then it kind of transitions into a square. And we kind of wanted to ease that off a little bit. And what I'm thinking is that we can just kind of merge many squares in between it and do ever so slight rotations all the way through. And I think that may work, but I don't know. So let's try it out. So I'm going to start off in Fusion as always. I'm going to be starting off actually with the actual arc that I'm working with. This is just going to be a pretty normal 3-point arc. We're going to be breaking it up into a few different ways. So I'm just going to make the center point exactly below the origin. Just going to make life a little bit easier. Make those both the same on either side. There's actually no need to add really complex dimensions, but I'm just going to use some numbers that are pretty easy to work with. I'm not trying to make life too hard for me. 25. Yeah, that sounds about right. So the idea is that you had a really sharp coil in between both ends. So I'm just going to put some points on either side. And I can make them symmetric by either using the symmetry tool, or I can just make them horizontally constrained to each other. So as soon as I move one, then the other moves along with it. And this is going to be the section for the sharp corners, or the sharp coils all the way through. And then it should start off a square on this end and then coil to the middle. And obviously, because this is a rotational part, I can actually copy one end to the other, but it's going to be this middle section that'll be a little tricky. One thing that's also going to be fairly interesting to do is to actually get a plane that is tangent to this arc, which is actually not super duper easy because you don't really know what tangent angle this is coming in at the bottom. But the main way to do it would be to go into construct and then click plane along path. That way I can just click on the path that I'm working on, and it works very, very similar to sweep, where if there's any points on this arc, it's actually going to be recognizing it as a point of interest. So it'll actually snap to that location. So I can't go any further than that point. It's at 100%. So I can just click OK. So this is the point that is totally perpendicular to this point of the arc. And that's where I can draw my square. I'm going to make it a center rectangle. And we'll call it 10 millimeters. That'll be all right. So the main idea with this is that we can sweep this profile along that path, and it gives us a square handle. That's pretty normal. But the cool thing is that we can come in there with our twist angle, and we can actually change this up. So if I go 90 degrees, then it's got a quarter rotation. If I do 360, then it's got a full rotation. So you can kind of see where I'm coming from, but it will always end and begin at perfectly straight squares. It doesn't lean at all unless I change this to something like 350, where it's, not a perfect angle. That square is now off angle about 10 degrees. So what I'm going to try to do is actually taper that angle along the way. So if I go back into sweep, I actually might be able to start and end it at certain points. And I'm going to try and end it at these noticeable points, but I don't know if it's going to work. I've got no idea. I don't actually want chain selection, so that it will actually snap to those points, will it? Oh, no, because they're not defined. Ah, gotcha. Okay. So I'm able to work it from there, but I'm not actually able to snap it on. Okay. So that means that I need to define these 2 points and then redraw that square on that line. That's fine. So let's say that the curved section wanted to be 40 millimeters. Let's make it 50. Let's go crazy.
This is insane.
Yeah. Calm down. Whoa. Okay. Is it actually snapping on that point if I uncheck chain tendency? No, it's not. Interesting. Okay. So will it snap to the middle, though? It will snap to the middle, but not to the edge. Interesting. So I don't know how far. So just so for everyone that doesn't know, the distance is currently 0.727. That is a decimal percentage of the arc length. So if I go all the way to the beginning, then that goes to 0. If I go all the way to the end, it is 1. Obviously, the snapping point in the middle is set to 50 because it's halfway through it. But it isn't snapping to these points. Now, I could figure this out mathematically, but then I would have to know the diameter and the radius and the angle selection of this. That's a lot of work. And annoyingly, you can't actually do it in Fusion. I don't know why, but you cannot do arc length dimensions. It's incredibly annoying. And so I'm just going to assume that it is, what, 0.75? 0.7? That's close enough. That's fine. So we'll see if we can sweep just that section. But like I said, I have no idea what I'm doing. I really don't. So it's a little bit before then. So let's say 50. Well, actually no, because I could just go to that middle snapping point. Oh, it's not even snapping there. Interesting. Oh, because it isn't the central point of that. Funky. Okay. So I could snap. So I could make it exactly down the middle, and then I could do a mirror across that face. But because I don't know where that starting point is, okay, all right, I'm figuring it out. I'm figuring it out as we go along. I actually want to do a break in this. I want to snap up this arc, so then these endpoints are actually. Oh, is it letting me do that? It isn't letting me cut it. Funky, funky, funky. Why did that just get deleted? Yeah. I'd like to break that, please. It's not letting me break the curve at that point. That's very strange. Okay. I'm going to fix down at that point and then make another arc there to that top point. And I'm going to be making the entire arc construction. So only this arc, or the fully defined arc, is the only one that I actually care about. And then let's see if I can redefine that. So it's not the main arc, it is just that one. So it's going to be starting off at the, well, let's just say the 1. So that's all the way at the end point. Great. And then I would like to sweep it along that entire path. And as long as I have, all the way along this one, there we go. And as long as I mess with my twist angle, as long as I make it in a series of, actually in a series of 90-degree rotations because of the square, then I can choose anything I want. So I go up to 720. Ooh, gosh, what is it? I can't do any math right now. Let's just keep it 360. That works for me. So my idea that I can go back and then continue this arc more and more and more with less rotation. And hopefully if I can continue that twist per arc length and kind of taper it off slowly, then I should be able to get to a straight section somewhere around here. But I still don't know. I still don't know what I'm doing. So let's try this out again. So I'm going to be making some more arcs from this section. And I'll just try, so I'll try a straight path and I'll just try one in the middle. There we go. No idea how much. 12.5, sure. I'm making this up as I go along. Let's sweep that along this path. But let's give it 180. Okay, so even though this is a less twist angle, because it's over a shorter distance, it actually doesn't work all that well. So I actually need to go way lower. So maybe 60. But even when I do that, I still get this funky angle. Do you see that, Josh?
Yeah,
it's
I
kind
do.
of coming in and then going off.
Yep.
So I think probably the trick is to then find an angle. Oh, it actually wants to be hiding that. Is to then find the angle that kind of gives you this illusion that this arc and this arc is actually tangent to each other.
It's pretty close. But isn't that just going to end up being the same arc?
That would be the exact same thing. So you'd actually have to split this up with many, many, many slight variations. So if you did 80, that's still pretty close. So I imagine you'd want to do basically 5-degree, maybe 10-degree offsets until you get a slower and slower and slower rotation. And I think this twist angle is the key. As long as you have this arc length, the exact same for all of the iterations as you go, less and less and less until it's just perfectly straight. And you reduce this twist angle, I think the amount that you go down in each section, that's going to be varying exactly how smooth that transition is. If you go too aggressive, you put it down to like 25, then it's a pretty obvious corner. And if you go 84, where it's only 1 degree less, then it's going to just take you so many iterations to go through that it's just a waste of your time, really.
So Derry said I used an S-spline as a guide rail for the sweep.
An S-spline, interesting. So going in here, that's where you'd make a coil that essentially goes along there. And I suppose you could taper that. I haven't used S-splines in so long that I don't even want to do anything stupid because I know I'm gonna send people down the wrong path. Uh, but I believe what Derek's talking about is the idea with using a series of splines that you can taper just a single corner, just a single edge of this coil as it falls along that path, and that the rotation per arc length actually gets reduced. And you should be able to configure that across the entire length of the arc. Derek, if you completed that, that's rad. That is so fantastic. But this would take me so long to do in real life that I actually don't want to waste any guys' time. Um, but if you can figure it out with T-splines, that's awesome. That's fantastic. Hats off to you, man, because that's fantastic.
So Ethan from Maker Faire OC, who is ECS or EC Spot on the Discord, if you go to the general discussion, so he's working on a truss system and he put a fusion file in there and he wondered if we could figure out what happened. He said, I'm having problem when I change base size from 8 to 10 inches. The model goes a bit wonky. He's sure he missed something. Can we have a look at
it? What page is it on?
It is the general discussion. Just if you scroll up just slightly, there's a 2x2 truss system Fusion 3
there we go.
file. Yep.
I'll get that downloaded and pulled into Fusion. One thing to know with Fusion files, it's rad, but for some reason it takes so long to actually not upload, but just to open. So I'll get this going in the background. While I'm doing this, Josh, I want to just give you a little starter of a rant, and then I want you to take it over, okay? Is 4-axis 3D printing overrated or underrated? Go.
4-axis, so you're talking about the rotational, so basically like a lathe in the middle that spins, or the head of the printer that moves?
The actual head of the printer.
Well, because when you're talking CNC machining, usually you're talking about adding like a lathe component as a fourth component, and you have that rotational ability, right? Okay, so the head of the thing can actually move. Is it overrated, underrated? It's a hard thing to broadly define, right? I think there are instances in which you can make some geometries in ways that would be difficult to do otherwise. So for the right application, I think it's probably okay. But that said, it feels to me like adding a fourth axis might just add so much complexity to the whole situation that you'd be better off making modifications to your design than you would making modifications to your machine to make it a fourth axis machine. I think the amount of effort that you'd have to put into defining those axes and slicing the models and like getting your printer to do what you want may not be worth it. That said, I still do like to see, I think from an experimentation standpoint, it's just fun to see how far these things can be pushed. So is it practical? Should people own them? Or is it like, probably not so much, but
I don't think it is.
But is it interesting? Yeah. It's like, it taps into the part of me that says, I don't know that we should do it, but the fact that we are is kind of fun.
I think it's probably way overrated. It seems to fall in that category of it's still too simple to be useful and it's really complicated. But if you then made a 5-axis, 6-axis 3D printer where it can actually go around and trail around a surface, obviously way higher difficulty, way higher complexity, but then you get a way more functional thing. But just adding one more axis to a 3D printer, actually, it makes it exponentially more complicated to deal with and not that much more cool. Do you know what I mean?
Yeah, definitely.
Just a little bit of info for people, which may be a little bit confusing. 3D printing is not don't work in 3D, which is very annoying. So I think we all know about a 2D printer, an inkjet printer, where it gives you a piece of paper and it's got stuff printed on it. I think we all kind of recognize how that works. It pushes a bit of paper in one direction, and then an ink head goes left and right, drops off a little bit of ink, and then it gives you it. So all the motions are moving in 2 axes at the same time. But 3D printers are not 3-axis machines. They're 2.5 dimension machines. They're 3-axis, but they don't use them. And the idea is that because 3D printers work in layers, they will trace around within an X and Y plane and then move upwards and then continue that. Not once are they moving in all 3 axes at the same time. And this isn't unique. There are some fairly inexpensive CNC mills that are 2.5. So instead of just doing, or it's not able to do really complicated, lovely curved surfaces, but for the pretty not geometrically complicated metal parts you need to do, where it's just a kind of a top-down profile, a 2.5 mil is what you need for the majority of people. That's perfectly fine. And I think coming into 3D printing and saying, oh, I want to do some 3D actions, it's like, yeah, you would need to move along diagonally and then trail up and down. And there's a few, I think CNC Kitchen did a video on that. But then to say, oh, while it's also moving diagonally and trailing up and down, and then also rotating or even tilting, it's like it already took PhD students to go from a 2.5 to a 3, that to go into a 4th dimension for like a desktop 3D printer, I just don't see it. I don't see it ever being useful or necessary for consumers at all. But if you're saying it's 6-axis, I completely see that for the industrial scale. That's completely fine. That's totally a market that I jive with. But yeah, fourth axis mods that I see for 3D printers, I'm like, it's just an unearthly amount of work for no pay, for actually a worse final product.
Yeah, I think they're not going to be widely adopted anytime soon. No. I wouldn't imagine. Right, you're going to have people that are printing from 4-axis, but again, because it's a research project, is what it is. It's not actually it's not about the outcome of the product for the most part. Yeah. Now, I mean, but I think, like I said, from an R&D standpoint, like if you're getting your PhD and you want to add a 4, 5, and 6-axis, and you're just making your way there, and because you can imagine some downstream applications to it, like that's kind of fun, just from a challenge standpoint. But to your point, yeah, very few people are going to use anything like this. Your 2.5-axis machine is going to do the vast majority of what you want it to do. It's going to break less. It's going to be easier to maintain. Yeah.
Sure. Now, I have seen 4-axis, 4-axis laser cutters, where instead of the laser beam just being vertical, it can actually change the angle as it cuts. And people will just take like a piece of acrylic or a piece of just random plastic, and they're able to actually angle it as it's lasering around an arc. And they can cut like turbine blades. I'm like, that's amazing. That's rad. That is exactly what 4-axis printing is for. That's ludicrously cool. But that's already something that you can make with a 2.5-axis printer. So maybe I'm in the minority, but I put that in the overrated category.
Yep.
Yeah. I think we should do that. I think we should do that once an episode. Hot takes on 3D printing, overrated or underrated. Yeah,
I like it. I wouldn't mind adding that to the show.
PTG, overrated or underrated? Overrated.
I mean, I think it's probably underrated. More people should use it.
No, actually, yeah. Okay, so another thing that I actually wanted to do on Fusion to actually test it is a project with the thread beginnings that we have on anytime we're working with bolts for the project. And it came from a YouTube comment that I'm actually really interested about. I don't think I have a single bolt. Do I? Kind of. So the idea with any type of threads you have on any screw, this is a terrible example. It's absolutely tiny. There's no way you're gonna. This is the only screw that I have.
No,
it's like an M2.
No. Just you're gonna have to just talk us through it. That's way too tiny.
Yeah, there's no way you're gonna see that. Anyway, the idea with the thread is that it's obviously a cylinder that has a coil cut into it. That's called a thread. Cool. But to actually screw a thread into a threaded hole, if you chamfer the very end of the thread, it makes it much easier to screw in. And we do this all the time in the book because we're constantly needing to make bolts because it's a really, really handy tool. And one of the things that we have to do is you make the thread and then do a revolute triangular cut to essentially cut it away. And a really, really common reaction with a lot of people is, why can't I just chamfer it and then add a thread onto it? And the reason why is fairly complicated to actually describe. And even when I show you with the 3D model, for a lot of people, it doesn't click. But then but if you 3D print it, then you totally understand it. And that's when it's really necessary. But we got a comment on Reddit or on YouTube about a different technique. And I haven't read it all the way through. Josh has, and I want you to actually talk me through it as I build it. So I'm going to be making a thread my way, then the wrong way with a chamfer, and then this random guy on YouTube who has a bit of a shortcut. And if it works fantastically, then rad. Then I'm going to use that way forever. So let me go ahead and share my screen. Oops, there we go. Oh, really quick, before we get onto that, we wanted to go over this model. Who did you say it was by? Completely forgot.
That was Ethan.
Ethan. Oh, yeah. All right. So he was saying that he made this truss system, 2x2 truss, but then when it came down to, did he say changing parameters, things got a little funky?
Yeah, he said, I'm having the problem when I change the base size from 8 to 10 inches. The model goes a bit wonky.
Okay, so I'm going to go into my parameters. Base size, this is currently set to 8. So let's change this to 10, see what the problem is. Yeah, I would say so. I would say something is off. So when I do that, it's actually highlighting 3 different chamfers down here in red. That might be the problem. But let's kind of creep up on it. Let's see if 9. Yeah, that gives us the same error. 8.5. 8.5 works. So there is a dimensional limit. Ooh, something's going on there. So as I creep up onto it, I go back down to 8.5. Okay. So I believe it has something to do with your chamfers are actually not they're not grooving. They're not working with everything. And it looks like, oh, these are all just bodies. Okay. So so this is immediately, I know what's going on. So this, Ethan, is a project that should have been made with components and joints, not with bodies. And this is a really fantastic illustration of the difference. So when you have a project that has just one object, just one body, it's really, really easy. You've got this top file here with the white cube, which is your component. This is like your big folder. And inside it contains the 3D object. That would be the body, but it also contains the sketches. That's the 2D sketches, and then any construction material. So the component is kind of like the container. It houses all the information. A lot of people get confused between the component and the 3D body because they're like, well, it's the same thing, right? And it's like, yeah. Imagine stepping into a house and not having any of the blueprints and trying to remake it versus stepping into a house and they already have the instructions and the blueprints in front of you. Which one is going to be easier to recreate? And it's going to be, well, it's the one where I have the instructions. And that's where it has all these sketches. So as you go through this should have been made by, instead of having just one component, but making multiple components inside of this and then using the joints to actually assemble all of this. So what's happening with the change parameters, if I set this to 8 inches, everything is groovy. And what I want you to notice is that this square opening is exactly offset from this outer square. So all of these walls have the exact same thickness to it, which is great. But as soon as I change my parameter from 8, right, increase that to like 8.5, then you can see it all goes out of whack. Now, this inner square is now actually translated a little bit. And now it has, different thicknesses all the way through. And some of my chamfers have actually disappeared. And that's just on the top section. If I go down here, yeah, you can actually see the wall gets incredibly thin there. This block is actually passing through, or this wooden arm is actually passing through the plastic part there. If you were to make this with different components and joints, then it means when you change the length of the wooden cross members, then because this wooden part is just joined to this component, they have nothing in relationship. When I change this part, it doesn't affect that part. So you actually want to start basically from scratch using these dimensions. And yeah, make sure this is just a top assembly and you make a brand new component for each of these parts instead of bodies. That's the idea. Ethan, if you want a little bit more information about joints and assemblies, that would be chapter 6 and 7 in the book. That's where we go over the difference between bodies and components. Yeah, that is a really cool project, but that's where you're going to be going wrong.
Yeah. So I think with the bolt, let's go ahead and just make a bolt with unchecking full length thread instead of going back to the original way that we did the bolt. If you want to do the bolt the way that we did it, by the way, that's chapter 3, is it?
Yeah. I'm just going to do one incredibly quickly.
Okay.
All right. So I'm just going to make just literally a threaded rod. So I'll make this 10 millimeters by 50. Fine.
Perfect.
Or yeah, that's fine. And then I can add on a thread to this. I'll make it modeled. Groovy. This is what an M10 thread looks like. One thing that I want you to notice is that as the thread spirals around the cylinder, it gets closer and closer to this top surface until it reaches an incredibly sharp corner right there. That's where the thread ends, and then it has to recede into the beginning of the thread. And this is really, really hard to screw into it. So one thing that we can do is actually make a sketch on that front section. We can make a very simple little equal-sided triangle. Whoops, totally screwed that one up. And because these, this is an equal triangle, or an equal right angle triangle, we know this is at a 45 degrees. So I'm just going to make this something like 4 millimeters. And then I can lower this down and then actually do a revolute cut of this triangle. Oh, whoops. Yep, that profile about the z-axis. And then it will cut away this outer edge. And it will leave me with a inner, or the beginning of the thread that is now inside a chamfer. So this makes it significantly easier to actually screw it in, especially when you're 3D printing this. Obviously, you wouldn't make one of these from scratch. You could just buy a bolt. But this is one of the ways to do it. The other way to do it would be to actually just make a cylinder, and then actually add on a chamfer beforehand. So if I make this again, 10 by 50.
This is not the YouTube version yet. This is a different.
Not yet. This is another way. Okay. So the other way that people go, oh, can I just add on a chamfer? Oops, we'll call it a 2 millimeter chamfer, and then add on a thread to this back section. And what you'll notice is that there is now no beginning to the thread that is actually on the chamfer. This thread actually ends behind this lip. It's kind of like taking a thread and then welding a big block of metal to the outside of it. It won't allow you to actually screw into it. So it's really, really important that we cut away some of that material. You can actually see that the top of this chamfer is on the same level with the thread, where on the other version, it is actually below the outer section of the thread. So it does allow you to slowly increase it. But Josh, what was this guy on YouTube saying?
The final one was to uncheck full length for the thread and then add a full length. Yeah, so let me just see if I can find the comment and see if I'll read it specifically. Let's see here.
So one thing you can do is you uncheck full length, and then you can actually maneuver maneuver, which is
so
the
the guy says it's much easier to uncheck full length on the threads and leave a 0.5 millimeter at each end. You can then use the chamfer tool. So try that. See what that
interesting.
does.
Okay, so I'm gonna say because he wants to leave 0.5 millimeter at either end, and this is a 50 millimeter long part, then I'm gonna make it 49 millimeters total, and then offset it 0.5 millimeters. So then I've got flat sections on either side, and then he said to then add a chamfer onto it. So that is, in fact, leaving us with a chamfer.
Yeah.
That's pretty good. Not bad. So what I am noticing, there's a weird corner. I don't know if you guys can see it right there.
Yeah, I do see it. That's funky.
Interesting.
Oh, interesting. It's cutting into it though. Wow.
Yeah, it is removing material, which is what you want. Fascinating. Okay. I actually want to 3D print all of these and actually see if this works in real life. Obviously, when you go and actually pull in a bolt, like if you go into Insert McMaster Car and then just pick any bolt you want. Oh, God, it's going to take for a while. Yeah, fully threaded. Yep. Any of these. Groovy. 3D step. Yep. Bring it in. Download. God, there's so many parts of McMaster Car. It's amazing. All right, and then we pull this upwards. So this does have a little bit of a chamfer on it, but it looks like the thread is actually being pulled in a little bit. Is it chamfered?
It is not. Oh,
it
yeah,
is not chamfered.
No,
no, it's
right
not. It's ending in a coil thread.
Right.
Funky. So the idea with the triangle revolve method is that it's kind of like you are cutting a thread on the lathe, and then you're holding a file at a 45-degree angle and just kind of touching off that outer corner. And because you're doing the filing afterwards, then it means that this angled section is actually cutting into the thread a little bit because it's obviously done afterwards. But this is actually a different type. Really funky. See if I can expand that. Show all the different sketches in it. No, it doesn't. That's annoying. So that must be a coil thread mechanism. Fascinating. All right. So yeah, I'd be really interested in actually 3D printing this one and seeing if it works as well as the normal Revolution cut. Because if it does, that's going to save a huge amount of time.
Yeah, that's a much easier solution if that.
Way easier.
Yeah.
All right. That's not bad. All right, Josh. I think I'm all done for the week.
That
almost made it to an hour. Not bad.
Yeah, no, I think that's fantastic. So we're just going to end it just a hair early today. But
right.
This has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we will see the amazing stuff that you make again next week. Cheers, everybody.
See you guys. Peace.